So last week you learned how to simplify radicals. Today you're learning how to perform operations with radicals. So we're going to start with adding and subtracting. And so like it says here, so just like regular numbers, so you can add your square roots together and you can't like combine apples and oranges. So kind of like if you have 7x plus 6y, they couldn't go together because they're unlike terms, which means so the radicand is the numbers under the square root there. So for this one, since you have 2 square root of 5 plus 4 square root of 5, since they're both square root of 5, they can be combined there. So pretty much you can think of it as like 2x plus 4x if you want. So for this one, so you can add the 2 and the 4 together here, so you'll get 6 then. And then you can think of it as like 2x plus 4x. So it'd be 6x, or here in this case, it'd be 6 square root of 5. That just stays there. It's not like you're adding the 5s and getting 10 or anything. So this would just be 6 square root of 5 then. And then for the one beside it, so you can do the same thing. So these are both square root of 7 then. So you're just doing 8 minus 2. So these can be combined because they have the same number under your radical symbol. So this would be 6 square root of 7 then. For subtracting the 8 and the 2. And then you can do the same thing on the next one here. So you have the square root of 5, 4 square root of 5, and then 2 square root of 3. So only the square root of 5 can go together. This last term won't be able to go with anything because you have the square root of 3 there. So for this one, so you can do 1 square root of 5 plus 4 square root of 5 then. So that'd be 5 square root of 5 for that one. And then your last term will just come down. And then you can do the same thing on the next one here. So you have the square root of 5 here, and then this other one down here. So these square roots of 5 can go together. So let's do this first. You have 1 square root of 5 plus 4 square root of 5. So that'd be 5 square root of 5 to start then. And then your constants, the negative 10 and the 7 can go together. So you're doing negative 10 plus 7. So that'd be negative 3 then. And then this is your answer. And then you can't combine them at all after that. And then you can do the same thing on the rest of the page here. So you have 3 square root of 3 plus 5 square root of 3. So these are the square root of 3. So these will go together. So 3 plus 5, so that'd be 8 then. So that'd be 8 square root of 3. And then for the next one, these are both square root of 2. So they can go together. So 5 square root of 2 minus 1 square root of 2. So that'd be 4 square root of 2. And then for the next one here, so you have 2 square root of 3 plus 3 square root of 7 minus the square root of 3 here. So your square roots of 3 can go together. This can't go, I think. So let's do this square root of 3 first. You have 2 square root of 3 minus 1 square root of 3 there. So that'd be 1 square root of 3, or just square root of 3 is fine. Just because you want to write it like the best way. And then you'll have plus 3 square root of 7, since that couldn't go with the others. And then on this next one here, so you have 6 minus 3 square root of 13 plus 3 square root of 2 minus 4 square root of 13. So the only thing that can go together here are your square roots of 13. It doesn't really matter what you have first. I'll just bring down the 6 to start. And so the 6 can't go with anything because that's your only constant there, like the number by itself. So then these square roots of 13 can go together. So negative 3 square root of 13 minus 4 square root of 13. So negative 3 minus 4, so that'd be negative 7 square root of 13. And then you'll have your plus 3 square root of 2 at the end. And this one here, like I said, it doesn't matter the order here, just as long as your signs are right. So that'd be the answer then. And then for these on the next page here, so you're gonna do the same thing that you did on the other side, but if you look at these to start, the 2 square root of 8 plus the square root of 2, these can't be combined to start because you have different numbers under your radical symbol here, because one of these has an 8 and one of these has a 2. But you're gonna take out as much as you can for both of these here so that you can combine them. So pretty much you'll, like this says here, you'll simplify the radicals before you add or subtract for these. For the ones in the top, there's nothing else. Like if you look here, like 13 is already prime, there's nothing else you can take out there. 2 is already prime, there's nothing else you can take out there. And the same thing on these, 2, 3, 7, 3, those are fine. For this one though, the 2 is prime, but you'll write out the prime factorization, the 8 first there. I'm gonna simplify this to start before we start combining anything. Okay, so you're gonna rewrite this one here. So the 2 still out front, and then you're writing out the prime factorization, the 8. So remember, if it's even, I'll take out as many 2's until you can't take any more 2's out. So you can divide the 8 by 2, which if you do, you'll get 2. I mean, if you do, you'll get 4, which you could take another 2 out, which would then give you 2. So really, it's 2 times 2 times 2 will give me the 8 there. And remember, it's a square root, so they'll come out in groups of 2. So these 2 2's can come out, and you'll multiply by that 2. So it'd be 4 square root of 2 for this one then. So that's what your first term is. You have 4 square root of 2, and this is still here. So since these are both square root of 2, these can be combined. So pretty much you're doing 4 plus 1. So this will be 5 square root of 2 for the answer here then. And then the next one here, you'll start out the same way. So these can't be combined at the start, but you'll see if you can simplify either radical any further. So 5 is already prime, so there's nothing else you can do there. But I'd write out the prime factorization of the 45 then for that one. So, okay, so I'll write this one over here. So 45, you can't take a 2 out because it's not even. So you can see if 3 goes into it. So if you divide the 45 by 3, then you'll get 15. And then you can take another 3 out of the 15. And if you do take a 3 out of the 15, then you're left with 5, which is also prime. So you can put that here too. So that's the prime factorization of 45. And they'll come out in groups of 2. So your group of 3's can come out here. So that'll be 3 times 7. So it'll be 21 square root of 5 then. Okay, so this is 10 square root of 5 that's still there. And this is now 21 square root of 5. So these can be combined. So you have 10 square root of 5 minus 21 square root of 5. So this would be negative 11 square root of 5 then. And then for the next one here, so you could combine your 2 and the 6. I'm just going to work on the other stuff to start though. So you can't combine what's in the square root to start because you have the square root of 12 and the square root of 27. So you'll simplify the radicals here. So you can write out the prime factorization of 12 to start. So I'll do it over here then. So 12 is even, so I would take a 2 out first. So if you take a 2 out of the 12, then you're down to 6. And you can take another 2 out of your 6, which would then be 3, which is also prime. And remember, they'll come out in groups of 2. So your 2's can come out here. So that would be 16 square root of 3. And then you can do the same thing with the 27 there, because it'll be 12 square root of 27 to start. And so you can take a 3 out there. I'm just going to box this. Hold on, sorry, I'm running out of room. So you come out with the prime factorization in the 27 there. So your 12 is still outside of it. So 27, so it's not even. So I would see if you can take a 3 out first, which if you do, then you'll get 9. And then you could take another 3 out of the 9. And then once you take a 3 out of the 9, then you'll have 3. So really you have 3 threes here, because 3 times 3 times 3 would give you the 27. And remember, they'll come out in groups of 2. So your set of 3s can come out here. So then you'll have this here. So you'll have 36 square root of 3 then for that one. And then you can just combine what you have after that. So you have, so this was 36 square root of 3. And then you'll add this other square root of 3 to it because this has a plus in front of it. So 36 square root of 3 plus 16 square root of 3 will give you 52 square root of 3 then. And then you can combine the 3 and or the 2 and the 6 there. So that would be plus 8 at the end of this. And then for your next one here, so you have 4 square root of 27. So you can write up, so the 3 is already simplified in the radical there. But you can try and simplify the square root of 27 there. So it's not even. So I would take out 3's and to see if 3 divides evenly into the 27. So if you do divide the 27 by 3, then you'll have 9. And then you can take another 3 out of the 9, which would then be 3. And then for every group of 2, you can bring one of them out. So these 3's will come out. So this would be 12 square root of 3 then. So this would be 12 square root of 3 plus 2 square root of 3. So these can go together since they're both square root of 3. So this would be 14 square root of 3 for the answer then. And then for the next one here, so 5 is already simplified in the radical, so you'll have to rewrite the 125 here to see if there's anything you can take out of that one, and then you can combine them later on. So you'll write out the prime factorization of the 125 then. So 2 is not going to go into it. If you try and divide by 3, it won't go in evenly, so you can try and divide by 5, which will go in. So if you do divide by 5, then you'll have 25, and then you take another 5 out of 25, which would then be 5. So there'll be 3 5s here, so you can, because they're all prime there. And if you multiply them, you'll get the 125, and then these 2 5s will come out. So this will be 30 square root of 5. And then these are both square root of 5, so you can go ahead and combine them. So 15 minus 30 is supposed to be negative 15 square root of 5 for that one then. For your next problem here, so so none of these 3 radicals are simplified. So you have to write the prime factorization for each one. I'm going to write this out before we take anything out to start. So you'll have this 3 on the outside here. So for 8, so you can divide by 2 first, which if you do, then you'll have 4, and then you take another 2 out of your 4, which would then be 2. So you'll have 3 2's here. And then for the 16, so you could take a 2 out first, and then you have 8, which would then be 2 times 2 times 2. So I'll have 4 2's there. Because that'd be 4 times another 2 would be 8, and then times another 2 would give you the 16 that you're trying to get there. And then for the square root of 72, so you can divide by 2 first, which would then give you 36. And then you take another 2 out of your 36, which would then be 18. And then you can divide your 18 by 2, which would then be 9. And then You couldn't take another 2 out of 9, but it would be 3 and 3 there, though. Okay, I'm going to write in a different color here so you can see the difference then. So once you've written these out, so for every group of 2, you'll bring one of them out. So these 2's can come out. So this would be times 2 there. So this would be, so for this one, this will be 6, because you have 2 times 3 there, and then square root of 2 there. This isn't our final answer. We're just doing this step. So that'd be there. And then you have this one here. So for every group of 2, you can bring one of them out. So this set of 2's can come out, and then this one will come out too. So you can do 2 times 2 times 2. So that'd be 8 then. And then you don't have anything left in the radical, so you're not going to bring it down because you wouldn't see it at all there. And then for your last term here, so remember every pair, you can bring one of them out. So this group of 2's will come out, and then this group of 3's. You'll have 2 times 3 on the outside, but this 2 will have to stay inside there. So this will be 6 square root of 2 then. Because you can multiply inside and you just have this 2 left. So your 8 couldn't go with anything, but these square roots of 2's couldn't go together. So you're doing 6 square root of 2 minus 6 square root of 2. So actually these 2 will cancel. So you'll just have your 8 left for the answer there then. So that's how to add and subtract. And then here we're talking about how to multiply radicals together. So for these, pretty much you're going to multiply whatever like number is outside of your radical symbol, and then you'll multiply the numbers inside. Although once you do that, sometimes you'll have to simplify the radicals after. So pretty much for this, you can multiply the numbers out front. So it'd be 1 times 1, so it'd be 1. And then you can multiply the numbers inside. So 2 times 3. So this would be like a 1 on the outside, so you'd have to write it. But then you can multiply the 2 times the 2 times the 8. I said 3. So that'd be the square root of 16 then here. And then you'll want to write these the best way. This actually is a perfect square. So you can go and take the square root of this. You'll get 4 here. Or you could write out the prime factorization here if you wanted, because you'd have 4 2's here. And then you could take out all these. Because then you'd have 2 times 2 on the outside, which is how we got the 4 also. So that'd be 4 there. And then for this next one, so you can like multiply the numbers outside and then the numbers inside. So this would be like 1 square root of 50. Or just square root of 50 is how I'll write it. You'll need to check and make sure the radicals simplify though here. Because for this one, so you'll write out the prime factorization for the 50 because it's not a perfect series. You couldn't just take the square of the whole thing like the 4 there. So for the 50, so you could take a 2 out first, and then if you do, you have 25. And then the prime that divides evenly into 25 would be 5. And then you're left with 5. So really you'll have 2 5's here. And then these can come out. So this will be 5 square root of 2 then for this one. And then here's the square root of 7 times square root of 7. So this would be the square root of 49 then. And that is a perfect square. So you can take it. So that'd be 7. And then for your next one here, so you multiply the numbers out front and then the numbers inside. So 36 times 5. I think it's 180, I feel like. So this would be 180 then. And then you'll have to write out the prime factorization, the 180, to see if it's already simplified or if there's anything else you can take out. So if you divide the 180 by 2, then you have 90. And you take another 2 out of 90, which would then be 45. And then once you're at 45, so you couldn't take a 2 out. So you can try and divide the 45 by 3, and then if you do, then you'll have 15. So you take another 3 out of the 15, and then you're left with the 5, which is also prime. So you can list that there. And then You can bring them out in groups of 2. So your group of 2s can come out and then 3. So it'd be 2 times 3 on the outside there then. So that'd be 6 square root of 5. And then, so you can do the same thing here. So you're multiplying the numbers out front and then inside. So this will be the square root of 30. And then you should check to see if there's any you can take out here though. So you can write the prime factorization for the 30. So you can take a 2 out, and then if you take a 2 out, then you have 15. And then the primes that multiply would be 15 would be 3 and 5. So you can list both of them here then. And then you don't have a pair anywhere here, so this will just stay a square root of 30 since there's nothing you could take out there. And then for this one, so you can multiply what's inside here. So 1 times 1, so 1, and then square root is 64. And this is a perfect square, so that'd be 8 then. And then for the next one here, so you can multiply the 13 times the 8. So, okay, so I know instead of actually multiplying together, I'll bring the 13 straight down, and then, because 13 is already prime, and then I'll write out the prime factorization, the 8. So for 8, you take a 2 out, and then you have 4, which would then be 2 and 2. So you'll have 8s here. And then a group of 2s can come out, but the others will stay. So you'll have 2 square root of 26 then. And then for this, so you multiply the numbers inside. So this would be the square root of 34 then. And then you can write the prime factorization of the 34 here then, which so you can take a 2 out of the 34, and if you do, then you have 17, which is also prime. So there's nothing you can take out on this one, because you don't have a pair of anything there then. That just say a square root of 34. Okay, so for these on the very back page here, so for these will be like the other ones there. Pretty much the ones you did here, you had like 1 in front, so it's 1 times 1, so you had a 1 out front still. So these pretty much you're just multiplying the numbers in front and then your numbers inside. So you're doing 2 times 4. So that'd be 8 first. And then you can multiply the numbers inside your radical symbols. So this would be 8 square root of 45 then. And then you should check and make sure that the 45 is completely simplified. So you're gonna have the prime factorization next to see if there's anything else you can take out. So you can take a 3 out of the 45, and if you do, then you get 15. So you can take another 3 out of the 15. And then if you take a 3 out of the 15, then you have 5. And then your group of 3s can come out here. So this would be times 3 then. So you'll have 24 square root of 5 then for that one. And then for your next one here, this will start off the same way. So you multiply your numbers in front and then the numbers inside. So 3 times 2, so that'd be 6. And then you multiply the numbers inside. So 6 times 8, so that'd be 48 then. And then you should write the prime factorization of the 48 to make sure there's nothing else you can take out. So it's even. So I divide by 2 until you can't anymore. So if you divide by 2 first, then you're down to 24. And then you take another 2 out, your 24, which would then be 12. And then 12, you take a 2 out, which would then be 6. And then from the 6, you take another 2. And so if you take a 2 out of the 6, then you're down to 3 then. And then for each pair, you can bring out one of them. So these both sets of 2s can come out. So you have times 2 times 2 then. So then you can multiply these. So 2 times 2 times 6, that'd be 24 square root of 3 then. And then for the next ones, you can start off the same way. These are just fractions here, but so you're multiplying the numbers out front. So you'll do 1/2 times 2/3, and then you'll multiply the numbers inside. So 1/2 times 2/3, if you multiply those together, then you'll have 1/3. So you'll have 1/3 on the outside. And then you multiply the 3 and the 8 inside. So that'd be the square root of 24 then. And then you'll write out the prime factorization of 24 to see if there's anything you can take out here. So you can take a 2 out first of the 24, which if you do, then you're at 12. And then you take another 2 out of the 12, which would then be 6. And then you can take a 2 out of the 6, which would then be 3, which is prime, so you can list it. And then you can bring out this set of 2's next. So you can multiply that by the 1/3 there. And then these, the 2 and the 3 have to stay inside. So 2 times 1/3 will be 2/3 then. So it's be 2/3 square root of 6. For the next one here, so you have 2 square root of 22 and you're squaring this quantity here. Instead of just teaching you the rules here, anything to remember, you're squaring this, pretty much you're going to multiply this by itself. So I'm just going to write it 2 times. So you have 2 square root of 22 and then 2 square root of 22 here, just because you're squaring it. I'm just writing out to make it easier. And then remember, after this, you're just multiplying the numbers out front. So 2 times 2, so this would be 4. And then you multiply the numbers inside. So 22 times 22, which if you do, you'll get 484. And then you could always check and write the prime factorization of the 484, but this is 484 is actually a perfect square, and you know this because you multiplied 22 by 22 to get it, which means the square root of 484 would be 22. So really, this 4 is still here, and this will be 22 then. And you can even take the square root of the 484, and you'll get 22 there. So this will just be 4 times 22 then. So it'd be 88 then. And like you could write the prime factorization for this, it would take a while, but it will give you the same thing no matter what. Because what you have, whoops, because what you have inside wouldn't cancel there. I mean, sorry, what you have would. So this would just be 88 there then. And then for the next one, so you multiply the numbers in front of the radical symbol. So it's 4 times 5 first. So that'd be 20, and then you can multiply the numbers inside your radical symbol. So 20 squared is 6. And then you can write the prime factorization of 6 if you want. It would just be 2 times 3 would be the prime, so it will multiply to be the 6. So you couldn't take anything out. This will just have to stay like that then. And then for number 6, you can start up the same way. So you multiply the numbers out in front of the radical. So 5 times 3, so this will be 15. And then 12 times 7, so that'd be 84 then. And then you can write the prime factorization, 84. This is even. So I would take 2's until there's no more 2's you can take out. So if you divide by 2, the 84, then you'll have 42. And then 42 still even, so you can take another 2 out of 42, which would then bring you down to 21. And then the prime that will go into 21, the next prime would be 3. So if you divide the 21 by 3, then you have 7. So you can list that because that's also a prime there. And then your group of 2's can come out. That'd be 30 squared root of 21. And then for your next one here, so you multiply the 4/5 times 1/7, and then you can multiply the numbers inside the radical symbol. So 4 times 1, so that'd be 4, and then 5 times 7. So see 4 over 35 then is the fraction. And then 13 times 5, so that'd be 65 then. And then you could check to make sure So you could, I'll do this up here in this color. So you write the prime factorization of 65. If you do, because you couldn't take a 2 off first, and then 3 is the next prime, which wouldn't go to 65. The next prime that would go into the 65 would be 5. And then if you divide by the 5, then you would get 13. So there's nothing you could take out there then. So it just has to stay like that for the answer. And then for the very last one here, so this would be like the other one you did there, you're squaring it. So I would just write this out because you're going to have 5 squared is 16. Since you're squaring it, you'll multiply it by itself again. So you can multiply the numbers out front. So 5 times 5, so that'd be 25. And then you can multiply it to 16 times 16, which is 256, I think. And then you can go ahead, this is the perfect square, the 256, or you can write the prime factorization, everything will come out. You wouldn't have anything left inside, so pretty much that will cancel. So it'd be 25 times 16 then. So then you'll have 400 for that one, and then okay, so you have a Google Doc to work on with the practice of the operations. Just let me know if you get stuck on these at all, because I know this is a lot mix of the stuff you learned before, and plus you have different rules for adding, subtracting, and multiplying here. Just make sure you remember, so when you're multiplying the numbers in front and then the numbers inside, and then taking out whatever you can. But when you're adding or subtracting, like up here, so they could only be combined if you have the same number under the radical symbol. So like these could go together, and then the negative 10 and 7. So they wouldn't, and then once you do combine them, it's not like what's inside the radical number would change at all. Just let me know if you need help though, and then you can also take a picture and send it to me if you don't have to type this stuff again like usual.